We are in the Atlantic Ocean, about 400 kilometers off the coast of Guinea, in West Africa. Recently, a large circular geological structure was discovered in this region, a crater that might be of impact origin. It may seem like just another one of the many craters we know, but there's a crucial detail that makes it extremely interesting. This crater dates back to about 66 million years ago, the same period as the famous Chicxulub crater, linked to the extinction of the dinosaurs. If the name Chicxulub doesn't sound familiar to you, it's the crater located on the Yucatan Peninsula in Mexico, associated with the asteroid impact that, according to the prevailing theory, caused the mass extinction that marked the end of the non-avian dinosaurs era. And here arises a question that could change our understanding of the planet's history. If the Nadir crater, as this new crater has been named, is indeed an impact crater and dates back to the same era as Chicxulub, is it possible that these two events are somehow connected? We might be facing one of the most fascinating and significant discoveries of the last few decades. The Earth is dotted with impact craters, though many have been erased or hidden by millions of years of geological activity. To date, we know of about 200 confirmed impact craters, distributed across various regions of the planet. However, most of them are concentrated on land, simply because it's easier to identify them there than on the ocean floor or in areas covered by vegetation. Among these craters, one stands out for its relevance in the history of life on Earth. The Chicxulub crater, formed about 66 million years ago on the Yucatan Peninsula in Mexico. This crater is considered crucial because it is associated with one of the most catastrophic events ever to occur on our planet: the mass extinction that marked the end of the dinosaur era and the beginning of a new chapter in the history of life. Although debates still exist within the scientific community, the prevailing hypothesis is that the impact that created Chicxulub triggered a series of devastating events: earthquakes, tsunamis, global fires, and an impact winter, caused by the dust and debris thrown into the atmosphere. These combined factors would have led to the extinction of about 75% of living species. A discovery published in Science Advances has brought to light a new underwater structure located off the coast of Guinea in West Africa. This crater, named Nadir, is buried under 400 meters of marine sediments and has a diameter of about 8.5 kilometers. Its circular structure, similar to other impact craters, exhibits numerous deformations and faulting, along with a central peak, all characteristics suggesting an impact origin. The discovery was almost accidental, as researchers were studying the seismic properties of the Guinea Plateau region. Using seismic waves to map the ocean floor, they identified this buried circular structure, which immediately sparked the interest of the scientific community. To better understand the significance of this discovery, we need to go back in time to 1980, when researchers Luis and Walter Alvarez proposed a revolutionary theory. While studying a thin layer of rock between the Cretaceous and Paleogene in Italy, specifically in the Botoccioni Gorge near the town of Gubbio, they discovered an unusually high amount of iridium, an element rare on Earth but common in asteroids. This discovery led to the formulation of the hypothesis that an asteroid struck Earth about 66 million years ago, causing the mass extinction that marked the end of the Cretaceous. However, at that time, the crater that would confirm this theory had not yet been found. The discovery of Chicxulub in the 1990s was the missing piece that confirmed the Alvarez hypothesis. The discovery of the Nadir crater has reopened a fascinating chapter in the study of cosmic impacts. Preliminary dating suggests that this crater dates back to about 66 million years ago, with a margin of error of about 800,000 years. This means that the Nadir impact could have occurred simultaneously with Chicxulub, or within a relatively short period around that time. There are two main theories that could explain the connection between the two craters. The first hypothesis is that the asteroid responsible for Chicxulub fragmented before reaching Earth, and one of the fragments created the Nadir crater. In this scenario, we could imagine a rain of debris hitting Earth in multiple locations, with devastating effects in several areas of the planet. The second hypothesis is that both craters are the result of an asteroid swarm that struck Earth at the same time. This scenario is rarer but not impossible, considering the complexity of the solar system's dynamics. If one of these hypotheses is confirmed, we would be facing one of the most significant discoveries of our time, capable of redefining our understanding of the events that shaped the history of life on Earth. Regardless of the connection to Chicxulub, the Nadir crater represents an extraordinary discovery. It offers us a unique opportunity to study another impact crater in relatively well-preserved conditions, which could provide new information on the global consequences of asteroid impacts. Future research will be crucial in determining the origin and exact dating of the Nadir crater. Ocean floor sampling and chemical analyses could provide decisive evidence to confirm the crater's impact nature and its temporal correlation with Chicxulub. Moreover, studying Nadir could contribute to improving models for predicting asteroid impact risks on Earth. Understanding the frequency and distribution of impacts in the past can help us better prepare for potential future events of this kind, which represent a real, though rare, threat to our planet. In conclusion, the discovery of the Nadir crater is a new piece in the complex puzzle of Earth's history. If its connection with Chicxulub is confirmed, we will have taken a significant step toward understanding how catastrophic events can influence the evolution of life on a global scale. But even if it turns out that Nadir is a separate event, it will still provide valuable insights into how Earth responds to large-scale impacts and how these events have shaped the surface of our planet. We have years of exciting research and discoveries ahead. Stay tuned to this channel for further updates and insights on Nadir, Chicxulub, and other wonders of the cosmos.